Hey guys, and welcome to the AzCloud Guy channel. This channel is really dedicated to show you guys simple cloud solutions from A to Z. Today, we're going to talk about DNS. What is DNS? So let's get ready, sit back, grab your pen and paper, and let's get to learning, guys. All right, so what is DNS? Well, DNS is essentially the address book for the internet. So if you think about a post office that handles your mail, right? It's responsible for ensuring your mail is delivered to the right address, being your house. Well, DNS performs that same functionality, however, for computers and devices on the internet. So as you perform lookups on your computer, as you browse websites, as you pass or copy data from your computer to another computer, send email. DNS is the agent that acts behind all of that processing that takes place. It also helps with routing. So as your device, of course, everybody has a home device that's connected to the internet. Well, that device has to know how to get from your network at home to whichever web server that you're trying to browse to, um, whichever email server that you're trying to send email from your computer to another computer. DNS is the lookup agent that helps with routing and connectivity for that traffic. So let's dive a little deeper today. We'll cover a lot of high level on what DNS is. Our next session, we will go through actually looking at how DNS works and actually some use cases in configuring DNS. So again, as I mentioned, DNS is really just the address book for the internet. It's maintained by 13 organizations. There's a governing body called ICANN. What that governing body does is essentially maintains simply almost a registry of DNS servers across the globe. There are 13 root DNS servers across the internet. And what that means is there are 13 servers that handle all of your DNS is hierarchical in nature, meaning that it's broken out by what we call root domains. So if you look at your a typical address, right? So this is a fully qualified address here, www.charttoheart.com. Well, this address has an IP associated with it, right? And the reason it has an IP is because computers pass traffic by what's called a network address. So every computer on the internet, albeit a computer in your home that's connected to the internet, or a server that's out in Mexico on the internet that's connected to the internet, has to have a unique address. And it's the goal of DNS to ensure that if that computer is hosting any type of service, for example, web server, well, that web server address has to be unique on the internet. So because you can't have two devices that both are assigned to the exact same namespace, right? You can't have two addresses in your subdivision that are the same. Everybody has a unique street number. Everybody has, for the most, from a perspective of looking at a house, right? The street number is your unique address, right? The street name may be the same, but the number to your house is specifically unique to your house. So in similar fashion, that's how DNS namespaces work. DNS addresses, they all have to be unique. So let's take a look at, I'm going to share my screen. Let's take a look at, for example, so on my machine, this is just a utility that allows me to kind of map out DNS addresses, right? So if I put this address in www.chapterheart, right? The way DNS works, everything starts with the root, which meaning in this case, the period acts as the root, right? What you don't see here, you don't really see the period on here because it really should be right here. So after each address, there's actually a period here that we don't typically have to enter that period because it's just known that the root, it really starts with the period, right? From a DNS perspective. So you start at the root and you work your way to the left, right? So the root would be here. This name here, .com, this is what's called a top level domain. So that represents a top level domain. And depending on where you're located in the world, this top level domain could be a country, what they call a country top level domain. So like if I was in Mexico and I pulled up a browser on the computer, it would default me to, let's say I pulled up Google, it would default to www.google.mx for Mexico, right? .com, it tends to be really used in the US. If you go to other countries, you'll notice that they use their own country code top level domain. If you're in Europe, it would be .eu. China would be .ch. India would be .in. So let's get back to what I was trying to explain to you guys here. So .com is a top level domain. Some other top level domains, .net, .edu, they're all used for different purposes, right? .org is typically used for nonprofits. .edu is mostly used for schools or universities. You have .mil, which is used for the military, the government, or .gov. Some government agencies use .gov, right? So that they all have different use cases for which top level domain you want to use. And those top level domains, they're managed or they're housed on these 13 what we call root servers. And these are root DNS servers that all they do is maintain a database of reference pointers for these specific root top level domains. So let's see that in action here. So if I go here, so let's put in a different address, right? Let's put in www.google.com, right? And let's see if I can make this a little bigger so you guys can see it. Hope you guys can see that. So let's see, I think that's as big as we're going to get it, right? So what this is telling us is that, hey, so google.com, this is the root server that was resolved for google.com, right? So basically, if I want to get to google.com, I'm going to hit this root server, which starts with the A. So there, like I said before, there are 13 root servers and they range from A to M. That's how they're named. And each root server resides in a different location around the world. And we'll see that, I'll show you that in a minute, just kind of a map, a visualization of how these servers are clustered and where they're located. So this record, www.google.com, so the path is telling me is that, hey, well, you need to go to root server A. Once you get to root server A, then you have all these other name servers, right? So this server, root server A, knows about all these other DNS servers that hold the record for www.google.com, right? So if we read this from my right to my left, your left to right, then this would read the root server.com. Then Google is the name server. I'm looking for a name server that houses Google's namespace. And what this root server is telling me is that, hey, these servers here, these 4 servers house this record. And the record I'm looking for here is www. So on each of these servers, the goal of a DNS server is to cache and hold your zone record for your domain. And that zone record will contain several different types of records. And I can show you an example here. Let's see here. So zone records will hold, these are a few types of zone records, more commonly used zone records. You have NSRR, which basically NS stands for name server, and the RR stands for resource record. This is really just a pointer to the DNS server that holds your record, right? An A record is typically an IP address. So this could be if you have a website, right? And we'll see this when I show you an example of a zone record. So this A record, what this telling me here in the diagram, so it tells me, okay, all of these servers hold an authoritative address for www.google.com, which is 172.217.64.68. So on this server, there's a www A record, and it's an A record because it's pointing to an IP address with that IP address on the server. If I had an email address with Google or Gmail, right, I would also find an MX record that lists the IP address or namespace for Google's mail server, right? A CNAME record is an alias record. Its purpose is really if I wanted to have, for example, if I had a website that had multiple pages to it, right? And let's say one of those pages was forms, right? So I could have an alias that points to that specific page on the website. So instead of this being www.google.com, if I had forms.google.com, I could create an alias CNAME record. I'm sorry, alias CNAME record on this server that points to that fully qualified domain name, forms.google.com. All right, so let's take a look. I'm going to just show you from a client perspective how this all works, right? So I have basically a command prompt up on my window, and that is kind of small there. So let me make this a little bigger for you guys so that we can all see this. There we go. All right. So on my client, my computer is connected to my home internet. And so what that means is that my router has given me an IP address. It has also given me a DNS server address. So if I run a simple command ipconfig all, what this will tell me is that it will give me the configuration for my computer's network interface card or wireless adapter, depending on which method you're connected to your home internet. So it tells me I have an IP address of 192.168.17.104. So this is my unique address for this computer in my house. It also will tell me a gateway address. This would be my router. So how I get out, what's the gateway, how I get out to the internet. And it will also give me these DNS servers, right? So I have two DNS servers here. These addresses are Google DNS servers. So what I've told my router here at home is, hey, when you assign an address to a computer, make sure it has these DNS servers. It has these DNS servers to reference for any lookups that are performed from this computer, right? So if I were to open a browser and put in www.yahoo.com, the first thing my computer is going to do using its client software. So every computer has a client, a DNS client piece of software called a DNS client. All that client does is looks up domain names, right? Because I need to know what IP address to send my computer to get to that namespace, right? And so I can do a lookup. A simple way to test my DNS, I can do a lookup and I can say www.yahoo.com. So what my computer's DNS client is going to do is say, hey, how do I get to yahoo.com, right? What's the IP address for www.yahoo.com? So this web server, which is www, for yahoo.com. Well, it's going to come back. It comes back and it gives me a name here, right? So from this namespace, these IP addresses are assigned to it, right? So I got like 3 or 4 IP addresses here for yahoo.com. So now that I know the IP address, my computer basically can go out, route to this IP address, and bring back the web page that I'm looking for. Each computer, once you look up an address on your computer, it caches that information to a database, a local database in your client on your computer. And let's see if I can show you that here real quick. Give me 1 second. Looks like my computer has just crashed on me. So let me go to another computer and we will take a look at this. While that's coming up, I'm going to show you these root servers. So here we have basically a map of all the root servers that exist, right? So you see there's several kind of location pops of root servers across the globe here. Each of these represent a kind of a cluster of root servers ranging from A to M. So if I were to drill in, let's look at the US here, right? Let's drag this over. So you can see in the US here, we have all these different locations where there are root DNS servers. If I click here, Georgia says there are 8 servers, right? And here are the 8 servers. I have an A server here, an F, an E, an L, a J, and a D. And if I kind of hover over, if I can make this bigger for you guys, if I can click one of these, it will give me the operator, which is the organization that's managing that server, VeriSign, which is one of the 13 organizations that maintain a root server. And here's the IP address for that server. It's 198.140.4. It says here there are 2 instances of that server, which means it's probably just a redundant. There are 2 copies of the server for redundancy purposes. Let's look at another one here. There's an L server. It's maintained by ICANN, which is one of the governing bodies. All right, and here's the IP address of that server. Right. Let's look at a different location here. Let's go up to Charlotte. It says there too. So this location only has really an E server, which is NASA, is maintained by NASA Research Center, and an F server, which is maintained by the Internet Systems Consortium organization. If I were to show you, let's look at a list of basically root servers. So here you have a list of the 13 root servers, right? This is really just consolidation of what I was showing you on the map there. So A through M, again, here are the IP addresses of those servers, and then here's the operator, which are the governing, the managing parties that are managing those servers. And as you can see here, they range from just organization businesses. There's university research centers, USC, University of Maryland. Again, you have NASA, you have the U.S. Department of Defense and Army Research. They maintain G and H root servers. We have VeriSign again, Cogent, which is a communications provider. They provide basically telecommunication services. So wireless internet to businesses and residences. Cool. All right, let's go back. I'm going to pull my computer back up here so we can continue. All right. And while it's coming up, so again, why is DNS important? And DNS is really important for two reasons, and that is really for routing and connectivity. Our computers have to have a way to both connect to and route to a given destination, albeit any web address we put in, any email we want to send, any file we want to save or upload or send to another party. Our computer has to have a way to get to its destination, and DNS is basically provides that functionality for our computers. Without it, there would be no internet, essentially. If you think about the internet as being just really a bunch of devices or computers that are connected physically in some form or fashion, right? Those computers connected together, and DNS is what drives the function of the internet, right? So without DNS, we wouldn't be able to communicate with anything outside of our main local network within our house or our businesses. Just to kind of reference some facts, DNS really is it's hierarchical in nature. Everything starts with the root, which is the period. And what matters it's before and after the period. What's important here to understand is that before the period is where you're going to have your root top level domain, being your .com, your .net, or your .edu. Right. Each DNS server, it will be of one of these types. You'll have a root server, which you've been talking about. There are 13 root servers. There are also what's called authoritative and non-authoritative servers. So given the basis that each server, there are multiple DNS servers across the globe, right? There are multiple organizations that host DNS servers. So let's say my ISP, my internet provider is Spectrum. So Spectrum more than likely will have its own DNS servers for its clientele, for its customers, its residences that it provides services to, right? And on its servers, they will have a pointer to one or two of these different root servers. And once that server has cached basically all of those queries on it, then that information is what our computers use when we talk out to the internet. So it's all about, it's really a big database of name, space addresses to IP addresses. So once your computer goes out and it knows how to get to Yahoo, meaning it's done a lookup and it's been provided the IP address back, well, it's going to cache that information locally on your computer. So the next time you need to go to a Yahoo, you will get a speedy, response, right? The web page will come up a little bit quicker or faster. The cache really helps with performance from the standpoint of being able to quickly connect or find the web server or address that you're looking for. Authoritative servers are the original servers. They're the owner of the record. Non-authoritative basically means that, well, this server is not the owner, it didn't hold the original record where the record was created, but I have a copy of your record. So because I have a copy, I can tell you where to go. All right, so my computer's back up. I'm going to pull up a command window again, and we're going to look at a quick sample of our cache on my computer, right? So we've already showed how we can do a lookup. And so the next thing we're going to show is, now that I've done that lookup, what it looks like in my cache. So I'm going to join, see here. All right, guys. Let's share screen and make sure we got our window up. Okay. All right, so what I have up here is just a basic command window. Let me make this bigger so that we're not killing our eyes here. Larger there, bigger font. All right, I think that's a lot better. All right, so I'm going to run a quick command, git DNS client cache. What I'm telling, this is what this command is doing. I'm telling it, hey, go out, look at my DNS, my local DNS client, and tell me what's in the cache, what is cached from me doing lookups to various addresses on this computer. So as you can see, what comes back is all of these different name space addresses, right? And it tells me the type of record that it found. So let's look at here for Google, right? Google.com. It found an A record. And it told me basically the time to live value, right? So this time to live value dictates how soon or how old this record is on a given server that it was located on, right? So this record here was located at this IP address, 142.250.105.99. And it has a time to live value of 98, right? This time to live value is in seconds, right? So what this means is that in 98 seconds, this record this record may change, right? And what you want to happen is that because DNS works on a caching system, if I create a new record on a DNS server, or a provider creates a new record on a DNS server, well, that information has to be cached locally to that server. It also propagates out to other DNS servers in the internet. That's really how DNS works. That's how each different servers can have a copy, a non-authoritative copy of a DNS record, is because that information is propagated to different servers throughout the internet. So as let's say I'm looking for www analogics.com, right, for an example, and my client doesn't know how to get there. Well, my DNS on my local machine, from what we looked at before, is pointed to, sorry, it's pointed to these DNS servers. So the first thing my computer is going to do, it's going to go look at this DNS server and say, hey, do you have a record of, or can you tell me how I can get to analogics.com? This DNS server will say, well, I don't know how to do that. I don't have a record for it on this server. So what I'm going to do, that server is then going to do a lookup, right? It's going to say, hey, based on what address it's pointing to for its lookups, it's going to go out and say, hey, I'm looking for this address, analogics.com. Do you know where it is? Right? So the next server in line will say, hey, well, I don't have a lookup, but I can give you a reference pointer, right? And that type of lookup it's called a recursive lookup, meaning that it's going to keep doing a lookup until it recurses or gets to a server that has the record that you're looking for. The next type of lookup is an iterative lookup, which means, well, I can't give you the exact address, but I can kind of point you to the right place. Most root servers that are out there in the internet, those 13 servers, they perform iterative lookups, meaning I can't give you the address, the direct address, but I can point you where to go, right? And so we saw that in our diagram, which I'll pull back up here. There we go. So I have my DNS analyzer. So the example I had up before, let's put Analogics in here. All right. So basically my computer, right, it doesn't really know how to get to Analogics. Well, you guys can't see my screen, I'm sorry. Let me share the screen so you can see what I'm looking at here. One second, guys. Let me share my entire screen. You guys can check this out. All right, here we go. So we have our tool up here, our analyzer tool. So I put in analogics.com here, and as you can see, it told me, well, hey, I'm going to send you to this root server, right? Because Google may not know how to get to it. My Google DNS server configuration. So it told me, hey, this A root server can point you to the right direction. So essentially it said, look for this name server, go to this name server, and then I will find a CNAME pointer, a CNAME record for www.analogics.com. All right. Let's look at another example here, just to mix this up a little bit. Let's go www.chart2hard.com. All right. So what this is telling me is that, hey, Same A root server, right? It's pointing me to a name server here, ns9.wixdns.com. So this DNS server, either one of these DNS server, I should be able to get to this domain from www.chart2heart. As you can see here, it did not give me an IP address as the previous example, right? But it did point me to the right place. So I can get essentially to this name server. This name server will get me to the www record, right? I'm going to go back to my window here, and I'm going to rerun this command so you can see that my cache now has updated. Right, so you see how my cache has changed here a little bit, right? If I put in, I'm going to put up a browser and just go to, let's go to analogics.com. Since that's already looked up here. All right, so it's telling me if I go back to my cache, right? Let's look at my cache, and you see my cache is updated, right? It stored some new information. See here, it found it has an entry now for a root server. So now I have an entry for this A root server, which is good because now if I have any issues getting to any web addresses or any fully qualified domain names, I have this root server cache now locally in my client, which will make my resolutions, my queries a lot faster. Let's go to a different site here, just to mix it up a little bit. So here I've gone to chart2heart.com. It's a pretty decent looking, this is a nice site. You guys should check out this site, Chart2Heart. I'm gonna go back to my cache. All right, so my cache did not update there. Let's do a lookup here. This is probably because so I just did a lookup for chart2heart.com, right? So my local client's done a lookup. It's brought back this Wix server, right? Which it tells me by the naming here that this is more than likely a load balance server because it says TD load, TD balancer, that their DNS are behind. And then this is the IP address for www.chart2heart.com. All right, so you can see it's referencing this Wix, again, this Wix server here. And as we saw in our diagram, this Wix server here. So we know that we are in the right place. Now, if I were to do just to show you the zone records that would be on this server, I'm going to do let's look up, and we'll say type equals A for a record, and let me Chart2Heart domain again. Actually, www.charttheheart. All right, so what this is telling me is that we just did a lookup, type A for a record against www or chart to heart, either way, chart to heart or www chart to heart, and it brought me back an address, which basically tells me that this record is an A record. Another way we can look at that is I'll pull up a browser and we can go to a different tool here. And I'm going to put in www.chart2heart. This tool is basically a DNS propagator tool. URL, basically you go here, put in your fully qualified name and the type of record. Here are the different types. We talked a little bit about a few of these. So I have a record selected because I know a record points to an IP address, and we know that this is in this address is an a record. And I hit search. So what this tells me is that, hey, this address has been propagated in these different locations, right, around the world. The server in New York, California, Atlanta, you have Mexico, even Brazil, right? So I can reach this domain, www.chart2heart. I know that I can reach it from any of these places here where it's been propagated. Canada, it's UK, right? And it gives basically the address of the server it found it on, right? So if we go look at, let's just look at one of these. Well, I apologize. I'm sorry. I gave you some wrong information here. That this address here is actually the record that it found on these servers in these different locations, right? So we know the IP address for chart2heart.com, which we saw here is 185.230.60.161, right? So that record, it should match, right? So here, this server here in California, it has the exact record or IP address for that website here. So what this tells me that more than likely at this location, it says this is Sprint. So this is a Sprint server that has a record for, it knows about www.chartheart.com. And it has the right IP address here to get to it. All right. So we've talked a little bit about what DNS is, how DNS works, and why it's important. So our next, during our next meeting, we will kind of go through how the configuration of this works. Or we'll have a few use cases. One for a website, right? How do I create a DNS record for my website? We will also look at how do I register a DNS record. So let's say I want to purchase a new DNS namespace, right? If I'm starting a business, my business is a cleaning company, and I want my fully qualified name to be godfreyscleaning.com. Well, I have to go purchase that domain name, right? And once I purchase it, I have to register it and then configure it for my website. So we'll talk about that next time, guys. I hope you guys enjoyed this stream and that you got something out of it and you learned something um, a little bit more about DNS that you didn't know. Um, till next time, guys, we'll see you guys next time on the AzCloud channel. Thanks.
Hey guys, if you ever wanted to learn more about cloud technology, have you ever asked yourself, well, what is the cloud? If the answer is yes to any of those questions, join me, the AzCloud Guy, on my YouTube channel as we explore simple cloud solutions from A to Z.